more things going on, and they do have their limitations. And of course, the biggest alternative are the dichotomous keys. And it's sort of the gold standard for plant identification, as you all know. They're authoritative, they're complete, they tend to have every species you can find in the state and all that. But there's a pretty steep learning curve on them. They're not something that many people are going to get really proficient at on their own, or it's going to take a long time. The terminology, I think there's 73 different words for hairs on a leaf, and that can get annoying, that can get difficult. And then sometimes you can get stuck with them. If you get into a genus where the fruits matter a lot, or it's looking at the differences in roots or the basal leaves or something like that, and you don't have that part of the plant, you're just stuck. And then you end up going to the end and working backwards, and it can get frustrating. They're also heavy to carry on hikes, and there's not enough pictures, even though Ackerfield has added a lot of pictures, which is nice. And those down at the bottom are just some of the ones that I think we're all used to spending a lot of time with. Ackerfield being the new one, the Webbers, and then the Flora of North America, which has all of North America, also online. But it can be difficult to use. And it's also a different user experience. If you're working with a dichotomous key, you're looking at that top picture. And if you're working with something else, you get lots of nice colors. And I think a lot of people prefer having the images to look at. So we're going to talk about what some of those options are. So some of the modern tools that help fill the gap between the old field guide books and the dichotomous keys, there's a big gap in between there. So we have these image recognition apps, and we're going to talk about how they work and how you can make them work better for you. And then we're going to compare the performance of 5 different apps. And then we're also going to talk a little bit about database keys, which keep you from getting stuck like you can if you don't have fruit or something like that with the dichotomous key. So to start, we're going to talk about image recognition and how does it work? How does the basic technology work? And Rob Raymond and I have created one of these, Colorado Wildflowers Guide. And Rob is the software engineer. Rob's the brains behind making it work. And so he's going to talk about the technical part about what's going on behind the scenes. And then we're going to come back around and actually show how they work in practice. So Rob, can you just talk over that now?
Sure. Okay. Yeah. Thanks, Ernie. Yeah, so I'm just going to give a little background on what image recognition is without boring you too much. So imagine it's springtime and you're out hiking and you see a gorgeous field of flowers and you pick out, a specific flower that you're interested in and identify it without consciously thinking about, what you just did. Flower recognition models are trying to do the same thing, same identification task, using machine learning. And sort of a buzzword, but it's basically having the computer do the identification for you. Machine learning is also known as neural networks, and it's really inspired by the structure of the brain where you have a connected series of neurons that are all firing, taking in the image from your eye and then trying to interpret it. And although there are machine learning models out there that can see in a big picture and pick out where the flowers are in a field, I'm just going to be talking about models that identify a species once you've focused on it. So you really need to help it along. So just like your eye chooses a flower to focus on, the photographer needs to choose a flower and to fill the field of view and then bring it into focus before taking the picture. And that's really the step that's probably the most important part, because once you've taken the photo, then the model does its best to basically determine what the species is. So the model takes as input the pixels from the photograph, just all the elements of the photograph, and then over on the right-hand side outputs a classification. And so the classification is just a list of species that it knows about, and the confidence in how well the photo matches the species that it knows about. It's ordered from most likely to the least likely. And so how does this model work? It's comparing your photograph to all the photographs of all the different species. And there's, hundreds of thousands of them, basically a lot of which Ernie took, that it was trained on. It does this by breaking the photo into like small sections and looking for different patterns and colors. And these small swatches get pulled into an overall weighting of what's the best match. So it's sort of a hierarchy of looking at the picture from little portions of it all the way up to the holistic view. But the model's only as good as the training data that it uses. So, and the weather, the time of day, the location, the maturity of the flower, the composition of the photograph, and kind of camera even make each photograph unique in some way. So the goal in assembling the training data is to capture some of the diversity of all these situations. And so the more diversity it has, the better, more flexible the model is to identify flower in whatever condition you happen to be in when you take the photo. So the diversity helps the model determine what part of the photo is salient or most important to identify the species, and try to take out maybe some of the background that might be different for all the different photos, or the lighting. So it's really, if it sees enough examples, it's going to figure out what's really unique about this species to be able to identify it. So Ernie, can you go to the next slide? So here's just some of the 1,082 images that we use to train for this species, Archilea millefolium. I'm not even sure if I'm saying that right. But so this is just an example of all the different angles and lighting and backgrounds that were used for this, just a subset of the images. But the idea here is that the machine learning model is trying to figure out really what is it about this species that will help it identify it in the future. So what I was going to do next is just do a quick demo of what the app is that Ernie and I have been working on. And then Ernie's going to go talk about how well a lot of different applications do at identifying species. So I'm going to share something. So Ernie, can you stop sharing for a sec? And I will share this. So I'm assuming you see this isn't a real phone. It's like a simulator of a phone, because to be able to share it on Zoom, this is really the best way to do it. And so this is the Colorado Wildflowers Guide app that we have, and so it just has a lot of great pictures that Ernie's taken. And in the top menu here is just some tips about how to best use the app. But really the meat of the functionality is here at this sort of search button on the lower right hand corner. And when you do that, you can search by a bunch of different criteria, like the flower color, the month of the bloom, the zone, and even by family. So you can pick a specific family. But the part we're really talking about today is the ability to identify it using the camera of your phone, or if you've already taken the photo, you can use your photo app to really pick which photo you want to analyze. So in this case, I'm going to pick a photo and just show you how that works. So here we have some sand lily photos. So if I pick one of these, it just ran the model that we were talking about earlier. And so here's the photo that you took, or that you had taken previously. And then it has a series of other photos where it's basically the classifications, the best guess for what's a match. And luckily in this case, the first guess is the sand lily, which is correct. But it also shows, the primrose, which, that was its second best guess. But it's, in this case, this was like, it was 90% certain that it was a sand lily, and just fractions of a percent in the primrose. If if it's really not sure or there's a lot of potential species match, there'll actually be more photos here until we sort of exhaust the most likely candidates. But the highest probability one always shows up to the right. So you can sort of understand sort of what the most likely to the least likely is. And then it's up to you really to see what the best match is in your mind in terms of what species that you've just taken.
Ray, could I interrupt for a second just and ask, you said that the sustainability identification was 90% and that the Anopheles espitosa was just a couple percent. So where do you see that? Is that information someplace else?
Yeah, that's a good question. What I had actually run the model where I can actually see the details, the classification, but we don't surface that. We don't really show that in the app, but that's a good point. That might be interesting to show, like sort of our confidence level, so that you can get a better feeling for how certain the model is about the species match. But yeah, in that case, when I was just talking, that was just based on sort of running the model outside of the app just to evaluate it.
Okay.
And that's actually another good point. If people are using this app and have other good ideas like that, Ernie and I are very open to hearing those. So, just get in touch with us. And we're trying to, over time, make it better. And Ernie's always taking more photos and getting more species in here so that it does a better job of identification. So, any other questions about the demo?
And so that app is one of the ones that I supplied the information for in the email, I believe. Would you mind giving that again?
So it's
Yeah.
called Colorado Wildflowers Guide, and I think maybe we could send out a link to it. So there's an Android version and an iPhone version to be able to find it, because sometimes those different app stores don't really, they show a lot of different choices. So but yeah, maybe we can follow up with more information about it.
Yeah, I think that the links that you sent out, Ann, were for the Android. There's a separate set of links for Apple, which we could send out later if people want them.
Yeah,
I think a lot of the people that use these apps actually tend to be Apple users. We're finding a lot more than Android users.
That's interesting.
The demographic thing, I think.
Could be.
All right. Well, with that,
But
I'm
we
going to
do have a
sharing.
question in the
Oh,
we
go
do
ahead.
have a question in the chat box from our Colorado friend from San Francisco, from Andrea. How many photos are in the training set? Are they all the ones that the both of you have taken?
So these are photos. Well, Ernie can give you a lot more detail, but I just wanted to blow his horn. Ernie took a large majority of these, and then he's also worked with other sources. But he's the flower expert. I'm just putting it into the app.
So what we do, different apps actually have different amounts of data, obviously. iNaturalist, which is one of the apps that we're going to look at, their data, which is a very big data set, is public domain. It's open to everybody. It's an open source data thing. So what we do is we go and download all the data they have for the species that we're interested in Colorado, and then filter through them based on quality. So we're training on about 300,000 images now, on 650 or so, 670 species. iNaturalist has several million images, and they're training on about 10,000 different species. And over time, as users like you folks use iNaturalist, your photos end up in their database, and then your photos end up being the training photos. And that's how over time all this technology is developing. Does that answer the question? I hope.
It does for me. I hope it does for Andrea.
Okay. So I'll go back to.
He says, yep, thank you.
I'll go back to this now. Okay, and we're back. Everybody back on my screen now, I hope?
Yep, we see it.
Yep.
Okay,
Achilles folium.
now I just got to get it to, okay. So as Rob just said, image quality is going to be really important. And I just said that, we get our data from iNaturalist. So this is, I just went to and downloaded, I said, iNaturalist, give me your photos of Tradescantia occidentalis. And it gave me, 1,000 images or whatever. And this is just a snapshot of what they look like. And as you can see, there's a pretty big range of quality. And this was also one of the things that made me want to kind of do this little seminars. Some of these images are going to work really well, and some of them aren't going to work very well at all. And so we're going to go through and talk about which ones are going to work and which ones aren't and why. So the first thing is you got to crop the image. So this is, does everybody, I guess I can't talk to you because I can't hear you guys very much. This is just an image that I took a couple days ago. I think you can see what the flower is. It's one of the only things blooming right now, the Townsendia hookeri. And I ran this through here in the middle. This is iNaturalist. And here off to the right is Colorado Wildflowers Guide. And you can see that neither one of them as a first choice picked Townsendia. And part of that, or probably most of that, is because the Townsendia flower itself is just a tiny little piece here in the image. And when the model doesn't necessarily know where to look in the image, it's just looking to see what's there. And it's not finding a whole lot of flower. So if we were to crop that image just like this and rerun it, now you can see that both apps came up with Townsendia at the top. iNaturalist came up with Townsendia excapa, and the Wildflower Guide came up with Townsendia hookeri. So right now we still don't really know. It's always good if you can, because both of these, all these apps, there's a lot of these apps that are free, or at least 3 of them are free. To do more than one maybe and see what the different models give you. One thing, so now we know that we have a good guess that it's probably Townsendia, and now maybe we can go to the dichotomous key and look at what's the difference between excapa and what's the difference between the hookeri, and maybe then we can refine our identification. But using this app has gotten us down to the genus at least, so it's given us a big help. One thing that I found, and I just ran this one photo, this was totally unexpected. Oops, that went before I wanted it to. I guess it doesn't matter. That's just pointing out that the iNaturalist will not only try to guess the species, it will also try to guess the genus, which can help you then if you want to go back to a dichotomous key or look elsewhere. One thing that's interesting is that this image, which isn't even a very good image after it's cropped, both of these models picked Paskflower as a second guess, which I found really surprising because it's not even in the same family. But there's something that these models see. They see something there that certainly I don't see. Maybe you guys can see it, that finds some similarities. The other thing is, now, why did iNaturalist pick Townsendia excapa where the Colorado Wildflowers Guide picked Townsendia hookeri? You might think, oh, that's because the Wildflower Guide had a better model, and that's actually not really what's going on here. What's going on is in the Wildflower Guide, excapa isn't one of the choices, so it couldn't pick it. The only, well, I guess there's 2 Townsendias in there, but it picked a hookeri because hookeri was there and it was a choice. In iNaturalist, it has both the excapa and the hookeri, but it has a lot more training data for the excapa than the hookeri. So the amount of training data for any particular species is going to influence the outcome. And that's going to be important because iNaturalist and a lot of these other apps, they're covering the whole world, at least the whole North America and often the whole world. So there's a lot of species there that it could pick. It could pick something that grows only in Florida because that's in the model. And the size and the number of images that it's training on can influence whether or not it's going to go towards something that only grows in Florida, or whether or not it's going to be a balanced model and could also pick, what the right answer is. The Colorado Wildflowers Guide is limited to just Colorado. So it's not going to go and find something that doesn't grow here, but at the same time, it's not as complete. So it might be missing something that does grow here. So there's different advantages and disadvantages for the various apps. And you just got to figure out which one's going to work for you in your particular situation.
Okay. Say, Ernie, before we go on, we got a couple questions here.
Okay.
Annie Miller wants to know, are photos of microscopic features included in the training database?
No, and that's actually something that we're going to get to or mention. No, see, and that's definitely going to be an issue. Like, so if you're looking at astragalus and you want to know if it has dobliform hairs or basally fixed hairs, you're not going to be able, that's not going to be in any of these. It's too small. And your photo from your phone's probably not going to capture that. And it's not going to be in the training data for either of them.
Okay. And a question here from Steve. He wants to know, does the app, I'm assuming he means your app, use location data to help in the ID?
Okay, and the answer to that is no, and actually none of them seem to be doing that. It's a really good question because it seems like, certainly for iNaturalist, which is trying to cover, the whole world, that if it got the GPS off of your phone, that it could help narrow it down. And that certainly could be done. I mean, technologically, there's no reason it can't. I think that maybe, and I don't know this is purely speculation, perhaps it's that then for every species, they would also have to have data on where that species could be found, which would be a lot of data for them to be working with in terms of having all these overlapping ranges. But no, none of them do seem to take location into account right now. I would expect 5 or 10 years down the line, they probably will, but they don't now.
Okay, thank you.
Okay, go on.
Yeah.
Okay, so if we go back to this Tradescantia screenshot, the question is like, why are there so many tiny flowers here? And I think that one of the issues here is this is Rob, who's a software engineer. We're getting him in, we're training him on botany, but he's a software engineer right now. And so he goes out in the field, like a lot of people, just kind of hold your phone and point at the ground. And when you're holding your phone and pointing at the ground, you're getting a pretty small image and it's not going to work well and it might be pretty frustrating. But if he bends down, he's going to get a much better picture. So a lot of it's just making the effort to bend down. And we've trained him that far. The next thing, we've got to get him to bend at the knees. So if you're bending a lot, use good form, but it's definitely worth taking the effort to get close to the flower and fill the frame with the flower and avoid those small images, because those small images where the flower is not dominant are just not going to perform well. He's actually learned quite a bit. He pronounced those flowers a lot better than he did a month ago. So the other thing that can help is, most cameras have zoom. When I'm out there doing this stuff, I just put my camera phone or my phone camera on 2x, just magnify it by 2 and just leave it there for the whole day. And then you don't have to bend quite as far. And again, that's something that's easy to do. You're going to get better pictures that way, and it's going to perform a lot better if you make that little change. Okay, another thing here is to have one species per image. So here's a picture where you can see the flower is small and it's in the middle, and then there's some leaves from another plant coming in. One thing, when the models are training, one thing it's looking for is edges, because the edges are going to help define shapes. And you can see that here, these leaves that are from a different species up here, they're in focus. There's edges there, so the model will pick up on that. You've also got a flower here that's purple and yellow that's in focus, and you've got leaves from another plant that are in focus. And if you look at what it predicted, well, it predicted something, it's the wrong species, obviously, but it has purple flowers with leaves that are somewhat similar to this leaf. And so by being far away, it picked something that was completely wrong based on the information we gave it, because we gave it some extraneous information. And once again, if we had cropped this, we would have, if we had cropped this or come in closer, we would have gotten rid of those leaves and we would have had the flower filling more of the photo. And when we do that and run that cropped image through, it nails it right on the right species. So again, it's easy to criticize the technology, and it'd be nice if the technology could figure this stuff out, but there's also a lot the user can do to make these things work better. Another one is focus. Because it's looking for edges, the edges come into focus or come into play when something's in focus. So here, we're back to Townsendia. We're gonna see a lot of Townsendia today because it's the only thing that was out there blooming. You can see that the camera has focused on the background a little bit. And by doing that, by focusing on the background, the model isn't seeing what it needs to see. And you were asking about, well, what are the scores? So here what I've done is I've gone in and I've gotten the data out of the model to see how did it score these things. And you can see that it put the rose heath at about 61% sure that it was rose heath on down, and the Townsendia was only 3% sure because it's out of focus. Now, if we take the same picture in focus, you can see that it's getting the right answer and it's 91% sure. So all it did was addressing the focus, really helped the model not only have a higher surety about its answer, the first place answer went from 60% to 91%, but it also got it right. So focus is going to be a really, really big deal. The two biggest deals are having the flower be big enough in the image and having it be in focus. And that's going to really make a difference in how well it performs for you. Another thing that can help is identifying features in the photo. So on the left there, we've got curly cup gumweed, but we've just got the picture of the flower. In this species, maybe that doesn't matter so much because it's a fairly distinctive flower. But the picture on the right, you can see you've got the recurved filaries, you've got the leaf margins. You're giving the model a lot more information. As long as that information's in the training data, and I think that generally these kind of macro features, not the micro features that were asked about before, but these macro features do tend to be in the training data, and it will help. So the picture on the right is more likely to have good success than the picture on the left. So here's one where this becomes even more obvious. So what do we have? I can't see anybody here. So anybody, people either through comments or by unmuting themselves, what flowers do you think we have here? Or are they the same or are they different? Nobody.
Nobody's gonna guess.
Yep. You will, Ann.
You have a 50% probability of being right.
So these are two different species, but when you just
They are two different species.
What's that?
Yeah.
Denise says they are two different
concur.
species.
Yeah, they are two different species, but you could see how they look very similar, right? They're two origerons, but they look very similar. And you could see how the model might have trouble telling them apart. But if you took the pictures like this, now you can see that this one has the long hairy filaries. This one has very thin glaucous filaries or glabrous filaries. And now you can see that these species look very different, and the model will pick up on that also. And it will separate those two species. So again, how you take the photo, including other characteristics, is going to help with the success when you're out there trying to use these tools. There are some genera that are going to be difficult.
Hold on, Ernie. We just had one comment I wanted to slip in here. Someone said that iNaturalist does use location data, lists seen nearby for local observations. Yes. And I don't know.
You're right.
What that means.
Yes. No, and that's a good point. It does say seen nearby. What I'm not convinced of, based on some of the wrong answers I get, where the right answer will be further down the list and it'll return a species that doesn't grow in Colorado, is I'm not sure that it's using that information in the modeling and in its selection of species. It might be. It does say seen nearby, but often even the seen nearby will be listed on species that don't grow in Colorado. Does that make sense? So I'm not sure how they're using it, but it's not always effective in that sense. But yeah, it does say that. It does have that.
Okay, and we have one more comment. Someone says that it, meaning iNaturalist, is also showing location data from the image. It recognized something I took in Loveland. That's not clear to me exactly. Andrea, do you want to unmute yourself and rephrase that question?
Sure. So I have photos that I took in Colorado, and it's noting that it was taken at a certain time in a certain general
Yes.
location based on the image, not have anything to do with where I am right now.
Yes, because your camera GPS is putting that in the metadata in the image.
Yeah, it's
So
the
the-
XF.
Right, so it knows where the photo was taken. It knows where the photo was taken. The question is, and I don't know, but the question is whether or not it's using that information when it's making the prediction.
That's the part I can't answer.
Right, and that's the
Or
part
maybe
I
it is,
can't
and it's in the
answer.
tiny little font. iNaturalist has little teeny tiny fonts, by the way.
But so that's the unknown, and maybe we should ask them. I mean, I could send them an email and ask them, what are they using the location data for? But yeah, but I don't know. But they do return species that don't grow in Colorado. So to what degree it's being used, I don't know.
Okay, thank you.
Okay.
Thank you, everyone.
So there are some genera that seem to be especially problematic. The ones that are problematic for us are also problematic for the model. You know, potentilla flowers can look very similar. The paintbrushes hybridize so much that if you look at the training data that's coming out of the research grade stuff from iNaturalist, it's really messy. They have a lot of misidentified stuff in their training data because the crowd, it's all crowd identified. The crowd is confusing things with all the hybridization. So the models don't work well there. Origerons, of course, are difficult all the time and stuff like that. So you would expect that these models are going to struggle on a lot of the same genera that we struggle with on our own. And they're going to do better on the ones that are more distinctive. Okay, so then what I did was I downloaded several thousand images from iNaturalist, unidentified images. I put them in I randomly selected 200 of them. And then I went through and I only used ones, of course, where I could tell what the right answer was, because otherwise we can't test whether or not it's getting the right prediction if I don't know what the right prediction is. So there's a little bit of a bias there. And then took 5 apps and put all 200 images through 5 apps to compare their performance. And these are the results. So here, the first row here is whether or not it got the right answer as the #1 choice. And then the second one is whether or not, the second row is whether or not it got the right answer as one of the top 3 choices. And you can see that iNaturalist by far has the best model. And this included photos that did not pass that test, where the flower was really small or the flower was out of focus. So this is what users are doing, not what a good user that's giving it a good picture in focus is going to get. So iNaturalist is right around 75 to 80%. It's getting it right. The Colorado Wildflowers Guide and an app called Picture This, we're getting right around 60%. And then PlantNet was a little bit lower. PlantSnap, to tell you the truth, I only went through 80 of the images because it was kind of a tedious process and it was performing so poorly, I didn't bother finishing on that one. PlantNet has a nice interface. PlantNet, to address your question, Ann, does report the score, the percent of confidence in their results, which is it's kind of a nice feature. But it seems like it's much more focused towards horticultural plants. It has a lot of house plants. It has a lot of garden plants, and it does much better on those than it does on native plants. And then Picture This does about the same as the Colorado Wildflowers Guide. If we go down, and I want to say that if you used good quality images, I would expect iNaturalist is probably going to be up around 90%, and the others will probably be up around 80 or 85%. So the quality of the image really matters, and iNaturalist actually is more robust in that it does better with poor quality images. One thing about a lot of these apps is that all of the apps except the Colorado Wildflowers Guide, when you take the picture and you say, tell me what this is, it's sending that back to the data server and then sending you back the answer, which means you have to have a data connection. The only one that doesn't require a data connection is the Colorado Wildflowers Guide, and there's some trade-offs there. The advantage is if you're out hiking and you don't have data service, you're in the mountains or something, the Colorado Wildflowers Guide will still work. The others won't. The downside is because it has to all fit on a phone, is the model's a little bit smaller and the model's not going to be quite as powerful. So what you can do is you can use, say, Colorado Wildflowers Guide while you're out hiking without a data connection. And then when you get back and you do have a data connection, you can run the same images through the other apps and see what they say. So the one that doesn't need a data connection is your instant gratification. And then the other ones can be used to confirm, or if the one without the data connection fails, then maybe one of the other ones will succeed. The other difference is that the Colorado Wildflowers Guide is specific to Colorado. You won't necessarily get the right answer, but the answer will grow in Colorado. And the others are not Colorado specific. And if you look at the errors, sometimes on the ones that were not Colorado specific, very often the error was that it was predicting the species that didn't grow in Colorado. With the Colorado Wildflowers Guide, because it's not as complete, it often had errors when the correct species wasn't one of the ones that was in the app. Say the app has a big bias towards the eastern half of the state right now. And so species that only grow on the western half of the state are less likely to be successful in that app. That's something that will be improved over the next few years, but that's where it's at now. iNaturalist, the Colorado Wildflowers Guide, and PlantNet are all free. Picture This has a subscription, either $3 a month or $20 per year. PlantSnap is $15. You pay once and then you have it. Some of them, 3 of the apps have a community kind of thing where you can interact with the other people. You can help identify flowers for other people that are there. Some of them have Facebook pages attached to it and things like that. Picture This and the Colorado Wildflowers Guide do not have that. So that's just a comparison of the advantages and disadvantages of 5 of the more commonly used apps for Colorado. Something about that was interesting, I just thought I'd throw this in, is by looking at all of the iNaturalist data, it was interesting to see what flowers people are using this in and what's the distribution. So on the x-axis there, you have how many species. So all the species were ranked based on how often they appeared in the iNaturalist observation data, and then the cumulative percent. And you can see that 50%, for flowering plants, there's about 2,500 different possible species that say would be in Ackerfield's flora of what we think of as pretty flowers. Well, not grasses, if you take out the grasses and things like that. 162 of those species, so about 6 or 7%, account for 50% of what people out there are actually looking at. So I thought that was pretty surprising. And 442 of those species account for 75% of the observations, and just under 1,000 of the species, so less than half of the species that a person might find, account for 90% of the observations. So it might make sense to make an app that has about 1,000 species, which will be a little over 90% of what's out there. And if you leave the rare stuff out there, you're less likely to get a bad prediction of something that's unlikely that somebody's looking at. Yeah, these are just Colorado observations, just the observations in Colorado. So this is just gonna be I'm just curious what all you folks out there think are the 10 most observed species in Colorado. So you can either unmute yourself and shout something out, or you can put it in comments and Ann can read them. But let's just take a minute. What do you think the 10 most observed species in Colorado are on the iNaturalist app?
Elephantella.
What was that?
Elephantella.
Oh, okay. Elephant head?
Yes.
Yeah.
Yeah, okay. That's one guess. Any other guesses?
Come
Don't
on.
be shy. Okay, we have a Columbine guess? That's it.
No, we have Alyssum simplex, which is a weed. Pinus ponderosa. 10 most observed species. Gunnison lily,
Okay, okay.
aspen, particularly when it's changing color. Mountain mahogany. Another guess.
Lilac.
Somebody said lilac. Somebody said pear cacti. I don't know what that one is.
Oh, prickly pear.
Oh, prickly pear. Yeah. Indian paintbrush. Somebody else says fringe sage. Somebody else said sunflowers, just sunflowers, no particular one. Were these supposed to be natives or could they be anything?
No, it's just, I mean, because people have the app in their hand, they can do whatever they want.
Hmm.
Okay, well, I'll go. We'll
Oh,
This is the-
Asclepias tuberosa. Okay, here we are. Here's the list.
Here's the list. So out of all the plants out there, 107, almost 108,000 observations in Colorado, the top 10 species accounted for 9% of all observations. And what I thought was interesting, especially for the Native Plant Society's perspective, 4 out of the 10 aren't even native.
Yeah.
So and common mullein, it was the most observed species in iNaturalist in Colorado. Then yarrow, milkweed, somebody said aspen, that was there. Dandelions, which when you think about it, they're easy to access. It's in everybody's yards. Columbine's there. Prickly pear, cactus was there, like people guessed. But it's a very non-normal distribution. It's very skewed towards a very few species right now. And whether that changes over time as more people start using these apps will be interesting to see. But that's what's there now. And weeds are pretty dominant on our landscape, or at least weeds get people's attention because they're looking at them a lot. Okay, so another tool that is not, we're gonna move away from the photo recognition and talk a little bit quickly about some database tools, which again are sort of in between your traditional field guide and a dichotomous key. And the two that we're gonna look at are, one's called Colorado Plants, put out by Flora ID. And the other one is an app that's called Colorado Wildflowers. It's a similar name, which makes it a little confusing. And so I don't know if any of you out there have used Flora ID. It's put out by Richard Olds and Bruce Barnes. There's 2 versions. There's a desktop version, which is $50, but you get free lifetime updates. I've had it for about 15 years and I've updated it 4 or 5 times and it's just, they just send you a new one. They also have 2 versions that go on, that are an app that can go on either a phone or a tablet. One includes everything, including grasses and conifers and spore-bearing plants, and that's $20. And for $10, you can get one that just has the non-graminoid angiosperms. I've used it on both the phone and the tablet. It's a little bit tight on the phone. There's a little bit too much information. I find it a little bit difficult on the phone. So when I use it, I usually will take a tablet with me in the field, but it will work on the phone. If you purchase it, the app, you can install it on multiple devices. So you can put it on your phone for when you're out there if you don't want to take your tablet with you. And then you can have the same app without paying twice and then use it on the tablet when you get home. Even though this isn't free, it's a nonprofit and all the proceeds, it's almost like the Native Plant Society. All the proceeds go to education and research and developing tools and things like that. So with that, I just want to real quickly demonstrate how it works. I'm going to try this with screen sharing has stopped. Okay, now I'm going to go back and screen share again. That's the goal. And here is this, and maybe I wanted to share 2. Maybe I can't do that. Just one at a time. Okay. Okay, so we're just going to be able to share one at a time here. So it's going to be a little different. So I can't have the picture of the flower. But we'll just do Townsendian hookery again, just because that's the theme. And what you do in a tool like this is you go through and you select certain characteristics. We can select the location. We know we're in Northeast Colorado. We can select a family. We know the family from looking at it. We might not know the genus, but we know the family. So we'll just go ahead and pick Asteraceae. And already now we've gone from 3,200 possible species down to 340. We can go, I'm not going to go all the way through this just to save time, but we can pick the main flower color as white. Now we're down to 102 species and they're listed here. And then it'll help you if you go up here and click on this little I, it stands for analyze. And what it's going to do then is it's going to tell you which characteristics are going to get you to the answer fastest. Let's just go to basal leaf shape. They're kind of linear. We're going to click on linear. And now you can see down here, we're down to 22 species. And luckily, the right answer is still there. And then if you want to look at them, you can click on this gallery. And now you can go through and find the one you're looking for. Now we're more like just looking in a book, and that we can go through and find what we want. There are hundreds of characteristics that you can go through here. It's going to go on the leaves, the petiole to basal ratio. It's going to go whether or not it has hairs, what's the venation, and all that stuff. It's very detailed and it's complete. It has every species in Colorado, and it can be a good tool if you're stuck. Now I'm going to go back and share. Okay, I'm going to share one. Since we're here, I'm just going to go ahead and share this wildflower search. This is a similar concept, but this is on an app. It's also a web page, but it's a web page or an app. Here we can set our location. We can set our observation time. It's the first week.
Okay, Ernie, we're not seeing your screen now.
You're not seeing my screen now. Go back to share screen. Can you see it now?
Yes.
Okay, so this is the wildflower search, which is also an app. It's a free app, and it's a database-driven app. You can pick your location on a map. Here I've picked Fort Collins. We can say that it's the first week in April. We can say that the flower petals are many, because we can say that the flower color is white. The flower size, I don't know, because very small, I don't know how they would do it. So I'm just going to ignore the size because I don't know the answer. And habitat, let's just say, if I can get down through here, let's say grassland. And now it has reduced the list down to 15. You can see that the right answer, Townsendia hookeri, is still there. But if we, we can go through and find and look. And then if we click on this, it's going to give us more information. It's going to have a map of where it's been found. I think a lot of this data comes from SciNet, but I'm not sure. It's going to tell you where you can look for more information, et cetera, et cetera. And it's going to tell you when it blooms, with the distribution and things like that. It's a nice app and it's free. And again, if your photo recognition is not working, you don't need a database. You don't need a data connection for this. It's self-contained, so you can take this in the mountains with you, and it can be pretty useful. Okay, so now I'm gonna stop sharing. I didn't want to do that. I wanted to stop sharing this, and now I'm gonna reshare.
I think there's just a slight delay.
There we go.
Okay.
We're back.
Yep, you're back. Colorado Plants Flora ID.
Uh-oh, but it took me all the way to the beginning. Okay.
Oh, okay.
I just got to get back to it. It
Yeah.
reset.
Yeah, Ernie, I just wanted to let you know that it's 1 minute to 8 according to my computer.
Okay, I'm real close. I
Okay,
think, okay, so this was that one. Okay, we're pretty much done. So the other thing is to confirm the ID, work backwards in a dichotomous key or forward if you know the genus. Also look at maps or other images. Real quick note on maps is BoneApp is a good source for maps. Acrofield's a good source for maps at the county level, and then SciNet and that app we just looked at in iNaturalist will have locations. This is just an example of what a BoneApp map looks like. If we zoom in on Colorado, you'll see that if you look for the species, if you were in Western Colorado, you probably got the wrong species. But if you were in Eastern Colorado, even if you were here in Crowley County, even though it's not lit up, it's probably still found there. These maps are all based on herbarium records and other, recognized records. And if you look here at what SciNet shows for this species, it would look like the species is really concentrated around Fort Collins, Boulder, Colorado Springs, and Pueblo. And that's not where the plant grows, that's where the people live. And so there are some biases in these maps based on where people are looking. So it doesn't mean that it doesn't grow in between these places. It just means that people aren't collecting it as much there. So some closing thoughts. Photos, get close up, be in focus, and have one species. If you don't get results that look right, try again, take another picture and try again. It can be a useful tool as a component. It's just one more tool in the toolbox. It's not the be all end all, but it works and can help. It's going to continue to get better. And I think as it gets better, people are going to be using it more and more. As more and more data is there for training, the quality of the recognition is just going to get better and better and better. Like somebody asked, for some species where the identification depends on the surface of a receptacle or the structure of a leaf hair or something like that, it might never work just because you can't see that in an image. Use multiple tools and then also be aware that sometimes it can help you get to the genus, which can be very useful in itself to go on from there. Did we make it in time?
oh, wow, you certainly did.
Kind of talk fast there at the end.
Yeah,
But with that, I'll just do the stop share. And if anybody has questions, have at it.
please. This is a good time to ask your questions. Well, I don't have a question, but I do have a comment. And that is, I have been with some pretty respectable botanists keying out plants that we collected from natural areas. And we've worked our way all through Acrofield and looked at hairs under microscopes and that kind of thing. And we get all the way to the end. Well, we say, okay, we think that this is probably the plant. Let's see what it looks like. So the last thing that we do after we've gone through the dichotomous key is to go ahead and see if the plant looks like the plant that we collected. So it's kind of the opposite of what you were talking about.
Right.
Yeah,
Exactly. Yeah, exactly. So you start with the dichotomous key and end with the picture as opposed to
Right.
beginning with the picture and
Yeah.
ending with the dichotomous key. And
Yeah.
you can do both. I mean, I think that the main thing is there isn't a right way to identify a plant. And I think that sometimes we can think that somehow if we're not using a dichotomous key, we're not doing it right, because that's how the professionals do it. And most of us, I see some of our professionals have left. So like Pam, but the professionals are going to be much more proficient with their dichotomous key, but most of us, I think we shouldn't be hesitant to use these other tools. They're going to get us there.
yeah, I agree.
And-
I agree.
Yeah, and so we don't want to be too, we don't want to feel bad because we can't use a dichotomous key. We want to figure out what else we can use.
Okay, you're getting some kudos rolling in here. Your app is really nice. Thank you for using iOS accessible fonts. I don't know what that means.
Neither do I, but Rob does.
Okay,
iOS is the Apple platform. So
Oh,
it's,
okay.
yeah, right. iOS is, iPhones, etc.
yeah. Okay.
Great. Well, I hope then that, that now the season's starting up, hopefully, while this is fresh, you can download some of these apps and compare them for yourselves and see which ones you like best. And hopefully they'll be useful. They've certainly been useful for me when I get stuck in keys, especially. Yeah.
So it's not cheating to use an app.
It's not cheating, and it's free, and they don't weigh anything. You already have your phone with you. So it's very easy to carry.
That's right.
All right. Over to you,
Okay.
Ann.
All right. Well, thank you very much, Ernie. Thank you very much. I keep calling him Ray.
Rob.
Rob Raymond, and I think he
Yeah.
muted himself. Thank you very much, everyone, for coming. And this will be our last Zoom meeting of the year. From now on, we're going to have field trips.
All right.
Like I said at the beginning, if you didn't catch the beginning, I'm going to be setting up a Zoom session. I know, another Zoom session to discuss when we might like to have field trips and come up with some field trip ideas. So if you want to have field trips this year, come to the meeting with your ideas, and you don't have to know every plant that's on the trail in order to be a leader on a field trip. All you really have to do is know where the trail is, know where we're going, lead people there, and serendipity happens while you're out on the trail, especially if you've got one of these wildflower apps on your phone. Okay, thank you, everybody. Okay.
Thanks,
Oh.
Ann.
One question left. Will Colorado Wildflowers become available for desktop?
Do you mean for photo
Yeah.
recognition? That's going to be up to people like Rob in terms of whether or not we can get that into the webpage. What's going to happen is the webpage is going to be updated to match the app, but have a lot more images and a lot more information. And it is a possibility that maybe the model could be incorporated so you could upload an image to it, but it's not there now.
Okay.
So maybe in a year, but not now.
Okay. More thanks.
Thank you.
All right. Thank you. Thank you, Ernie. Thank you, Rob. Thank you, everybody, for attending. Have a-
Bye-bye.
All right. Bye-bye.
Good job.
Yeah, I think it was a good talk.